Good afternoon, students. I hope you must completed Unit 1. Now today we are going to start Unit 2, Inverse Trigonometrical Functions. Now in the last chapter we have seen that only 1 and onto functions are invertible. We know that trigonometrical functions are not 1 over the whole domain and hence inverse do not exist. But when we restrict it to a part of the domain where the function is 1, then it is said to be invertible on that part only. In this chapter, we shall restrict the domain of the trigonometrical function to ensure the existence of their inverse. Listen again. Now here we know in the last chapter when the inverse of a function exists when the function is 1 and onto. Now our topic is what? Inverse trigonometrical functions. It means we have to find out the inverse of all the trigonometrical functions, sin x, cos x, tan x, etc. Now here we know that the trigonometrical functions are not 1 over the whole domain. We know sin pi by 6 is what? 1 by 2. Again sin pi by 6 is what? 1 by 2. Similarly sin pi by 3 is what? Under root 3 by 2. And again sin 2 pi by 3 is what? Under root 3 by 2. It means our function is not one. Same value have the different values have the same image. So we can say that trigonometrical functions are not 1 over the whole domain and hence inverse do not exist. But when we restrict it to a part of the domain where the function is 1, then it is said to be invertible on that part only. Now in this chapter we shall restrict the domain of trigonometrical function to ensure the existence of their inverse. Let us see first sine function. Now here let us consider the sine function f defined by fx equal to sine x. And now we know the domain of the sine function is what? The set of real number, because sine x can be defined for every value of x. Therefore, the domain of the function is what? The set of real number. And we know the value of sine x always lies between what? 1 and -1. Therefore, the range of this function is closed interval -1 to 1. Therefore, here in the whole domain, this function is not 1 because the different values of theta may have same value. Therefore, f is not 1. But if we take this interval, closed interval minus pi by 2 to pi by 2, just see in the figure, this is the graph of sine function. This is the graph of what? Sine function. Whenever you have to draw the graph of any function, then you can take one variable x, another variable y. Then putting the value of x and getting the value of y, we can plot on the graph. When we are drawing the graph of fx equal to sine x by taking it is 0, pi by 6, pi by 4, pi by 2, pi like these values, then it will be the graph of what? Sine function. It is known as what? Sine curve also. But when we consider this value minus this interval minus pi by 2 to pi by 2, as the value of x changes, the value of y also changes in this interval. Now here in this interval we can say our function is what? 1. So therefore we can take, if we take interval close interval minus pi by 2 to pi by 2, we see that the function is what? 1. And it is also on 2 because it is the range is what? -1 to 1. But if we take this, now y equal to fx equal to sine x with domain close interval minus pi by 2 to pi by 2 and range -1 to 1. When you define this function from this domain to this range, then we can say the function is what? 1 and onto. Therefore, as the function is 1 and onto, it must has the inverse. So therefore, y equal to fx equal to sine x with this domain and this range has an inverse function and denoted by sine inverse. Denoted by what? Sine inverse or arc sine, or generally we denote it by what? Sine inverse, but sometime it is also denoted by arc sine. and written as y equal to sine inverse x. This is the definition of what? Inverse function, because we in the last chapter we know only the function is invertible when it is 1 1 and on 2. Now we have taken only this interval of the domain, and in this interval we have seen our function is what? 1 1 and on 2. So we can say from this interval to this range the function is what? 1 1 and on 2, and then we can find out the inverse of this function in this domain and in this range. It means it has an inverse function, and it is noted by sine inverse and written as y equal to sine inverse x. Now that therefore f is a function from what? From this domain to this domain to this inverse. So therefore sine inverse will be a function from what? This domain to this range, because it is the inverse function. Domain and range, they will interchange. Now therefore we can say here, so sine inverse is a function from what? From this domain to this range. Now in the case of inverse, therefore domain of sine inverse x will be what? Close interval minus 1 to 1, and range of the function is what? Close interval minus pi by 2 to pi by 2. Now here beside this interval there are other interval also where the sign is 1 1 and has an inverse, but here by sine inverse x mean we shall mean the function starting from what? Close interval minus 1 1 to close interval minus pi by 2 to pi by 2, because we have find out the domain in this interval. This is the domain, this is the range, but when we are talking about the inverse, then it becomes what? It becomes domain, it becomes range. So therefore sine inverse is a function from close interval minus 1 1 to close interval minus pi by 2 to pi by 2, and this value of y lying between minus pi by 2 pi by 2 is known as principal value branch of sine inverse x. This is known as also the range of the function we can say, and it is also known as the principal value branch of the sine inverse x, and the value of y are known as what? Principal values. Listen it again, this point is again, we have considered only this interval, close interval minus pi by 2 to pi by 2. But there are some other interval also where our sine function is 1 1 and has an inverse. But in our syllabus we have taken only this interval, and the value of y lying between this interval is known as the principal value branch of the sine inverse x, or we can say it is the range of sine inverse function, and the value of y are known as what? Principal value. This is just the introduction where we are defining sine inverse function. Now here similarly in the case of cosine function is cosine cos x. So therefore the domain of the function is R, and again cos x lies between 1 and minus 1. So therefore the range of function is close interval minus 1 to 1. Again when we consider the whole domain of the function is not 1 1. So therefore again likewise in the case of sin x, we restrict the domain of this from close interval 0 to pi. When we consider this interval, it means the first quadrant and the second quadrant, the value of cos will not be repeating. In the first quadrant all the values are what? Positive. In the second quadrant all the value of cos are what? Negative. If we restrict the domain of the cos function in this interval 0 to pi, function is what? 1 1 and has an inverse function called the inverse cosine function and written as y equal to cos inverse x. So therefore the domain of cos inverse x is what? Minus 1 1, and the range of cos inverse x is what? 0 to pi. So therefore again this value of y lying between what? 0 to pi, that is known as what? Principal value branch of the cos inverse function, and the values of y are called the principal value. Similarly, we can find out the domain and the range of the tan inverse function also. Again, define fx equal to tan x. Domain of the function is R except odd multiple of pi by 2, because tan pi by 2 cannot be defined. So therefore, here the domain of the function is what? The set of real number except odd multiple of pi by 2, and range of the function equal to r, because the tan theta can go up to infinity. So therefore the range of the function is equal to r, the set of real number. Again in this domain the function is not 1 1. Again we can take a part of this domain to make our function what? Invertible, when we consider the open interval minus pi by 2 to pi by 2 in the case of tan x. In this interval the function is what? 1 1, and has an inverse function and called inverse of the tangent function, and written as y equal to tan inverse x. And now here the domain of tan inverse x is R, and its range is open interval minus pi by 2 to pi by 2. And the value of y lying in this range is known as what? Principal value of the tan inverse function, and the values of y are called what? Principal values. And moreover, we just briefing the whole this into a table that we have to memorize. Only the role of this table is there in the trigonometrical inverse function. Only we have to learn this table, that is considered to memory. The earlier portion that I am explained, that is just the introduction from where inverse trigonometrical functions are arising. But in our, to sum up all this, we have this table. We have to, this is the function, this is the domain, and this is the range. Y equal to sine inverse x. The domain is what? Close interval minus 1 to 1. And the range or the principal value branch is what? Close interval minus pi by 2 to pi by 2. Then I have taken sine tan inverse x, then cosecant inverse x. These three trigonometrical inverse function I have taken together because somehow their range is what? Here it is close interval minus pi by 2 to pi by 2. Here in the case of tan inverse x, it is the open interval minus pi by 2 to pi by 2. And in the case of cosecant inverse x, then the range is what? Close interval minus pi by 2 to pi by 2 minus element 0, because we sine 0 is 0, and here the when we find out the value of what? Cosecant 0, it is not defined. Cosecant is not defined at the point 0. So therefore here in the range is what? Close interval minus pi by 2 pi by 2 minus 0. Just 3. Here domain is minus 1 to 1. Range is this. Again tan inverse x. Domain is R. Range is, or the principal value branch is open interval minus pi by 2 to pi by 2. Then in the case of cosecant inverse x, the domain is the set of real number minus open interval minus 1 to 1. And the range is close interval minus pi by 2 to minus pi by 2 to pi by 2 minus 0. Similarly, in the case of cos inverse x, again the domain is what? Minus 1 to 1. And here the range is close interval 0 to pi. In the case of cot inverse x, the domain is R. Again the range is open interval 0 to pi. Similarly, in the case of secant inverse x, the range is what? Domain is what? R minus open interval minus 1 to 1. And here the range is what? Close interval 0 to pi minus pi by 2, because cos pi by 2 is 0. Therefore, the secant pi by 2 is not defined. So, only this table we have to learn for what? Inverse trigonometrical function, that will be help us in solving our question. The briefing is only this table we have to learn. Again, see it here. Now I have taken these three functions together because in this case the range is almost the same. And in this three inverse trigonometrical function, again the range is what? Almost the same. They are lying almost in the interval 0 to pi. They are lying in the interval minus pi by 2, pi by 2. So this table help us in solving our question. Now here, when I am introducing the sine inverse function and the cos inverse function, I have also told that there are some other intervals also in which the function is 1 1. So this are the branches of the range other than principal value branch. But in our question, we only use the principal value branch. But sometime in the examination, in 1 marks question, it can be asked that we have to tell the other value of the range other than the principal value branch. So only one value you have to learn for all these inverse trigonometrical function. These are the other intervals of various inverse trigonometrical function where our function is what? 1. So this only you can learn only one interval other than the principal value branch of all the inverse trigonometrical function. These are the different intervals of different inverse trigonometrical function.